Thank you for coming. No, after lunchtime always is difficult. So this is not going to be an economical presentation or something difficult to understand. We are going to try to make almost 10 experiments related on safety of LNG. Every 5 minutes, we will have one experiment. So I try to do it different. Well, so the purpose of this is to give a basic, basic understanding of the properties, physical and chemical of the LNG, but always related with its safety. Okay. So let's begin. Imagine you are in front of an LNG tank on board of a ship, or a huge and big full containment tank in an import terminal. I know, but I'm going to ask you. I would like you, the audience, to participate, and I, with questions and some time coming here to the stage. Okay, but imagine you are in front of LNG tank. Have you ever had the curiosity to look inside? Yes, to look what is happening there. Who says that it's like water? Raise your hand. Okay. And who says it's like marine diesel oil, for example, if you look inside the tank? Right. Who says I have no idea? Okay, lot of hands. Very good. So, well, let's go to open an imaginary window and have a look. Excuse me, because this is dangerous. So, okay. Let's open a window inside the tank. First of all, we have to cool down a little bit the glass in order to avoid it breaks. And then we can put more and more. Okay. Okay, so this very nice picture is an imaginary window inside the tank. Okay. What you have here is what you have on ships, LNG ships or LNG tanks, and it's a boiling liquid. It's that boiling liquid. So it's not water. It not remains nothing. Inside the tank, the LNG is boiling. Okay. So lights, please. Thank you. Enjoy the image. Okay. So, be careful. No. Okay. Now, you know that LNG boils 160 degrees Celsius below zero, 256 degrees Fahrenheit below zero. So tell me, what in this room is warmer than minus 160 degrees? Everything, everything. So if LNG touches everything or anything, it will boil. So it's one of the properties. When you spill out LNG on floor, of course, listen, it makes funny sounds. But the more important thing I want you to remember is that it disappears. It's different from other hydrocarbon fuels that, for example, gasoline. It remains there. LNG disappear. And to demonstrate that, I will need a victim from the audience. I will need a brave volunteer. So let's go to the last row. Okay, the red one. Okay, thank you. Okay, please. So your name, please. Álvaro, I want you to sit here, please. No, no, no. No te lleves la mesa. No. I know that. Thank you, please. But, well, what don't do that at home, please. I want you to remember that LNG boils and disappears. And what I'm going to say, Álvaro, is I am going to pour here a little bit of LNG. I will count 5. Pour again. I will count 5. Pour again. I will count 5. And then pour the LNG over your head, okay? Yes.
Are you sure?
No, are you brave? Okay. So please. So so remember that LNG will vaporize. I hope. Okay. You hope so. Yeah. Okay. So 1, 2, 3, 4. Smile, please. Smile. Okay. Okay. 1, 2, 3, 4, 5.
Can we just wait?
1, 2, 3, 4, 5. Please. Okay. So, thank you so much. Okay. Okay. So. Okay, let's continue with other properties of the LNG. Is that the LNG, it has extremely ultra cold temperature. Okay, so it will stiffen, it will brittle almost or crystallize almost everything. So I will need now 2 more volunteers, not so brave like Álvaro. Another 2 more volunteers, possible female, please. Come on, please. Glass and gloves, please. Glass and gloves. Okay. And another one, please. It's. Come on. And glass and gloves for her also. So, well, so this is a live bean. It's live, it's very flexible rose. It's composed by water and proteins, so it's very flexible. But after 10 seconds inside the LNG, it will lose its flexibility. And this flexible rose will transform in a crystal rose. So I want you, please, take the rose and put slowly onto the LNG, into the LNG, like that.
That's not slowly.
Okay. Please. the roses are hot, the hot part, and LNG is boiling. So, okay, remain like that, and please leave me, excuse me. Yeah, excuse me, move to the left. Okay, take the rose, also you. The camera, please, around here, and with the other hand, one by one, stiffen, and listen, please, the sound. Okay? So it's like a crystal rose, okay? So, yes. No, it's very nice. It's okay. So, well, give an applause. Ponelo para allá. Okay. Yeah. Thank you very much. But now I want to do it with regular carbon steel. So, okay. Regular carbon steel, you know, we have here a magnet. You know, a magnet attached to the carbon steel, but magnets do not attach to stainless steel, okay? So it's regular carbon steel. In normal conditions, carbon steel is very tough. You can flat it without any problem, and you can flat it, and it remains its integrity. Doesn't break, okay? But what happens if we put regular carbon steel inside LNG? Well, it's like a pipe, okay? So, well, and excuse me, I am going now to, with the hammer, try to give some poof poof. I don't have to say that, and because I don't want any little piece of pipe go to the audience, I am going to do down the table, okay? Okay. Magnet. So this is we have. Okay. Where is the camera? Please, we have a video of this. Could you put video? This video was performed last week. You know, it's like crystal and well, I removed the sound because I was speaking in Spanish, okay? I want to say that 90% of the videos we are going to see here was performed especially for this Madrid LNG Congress. Okay, let's move now to the second part of the presentation. And I would like try to explain how to fill up properly a tank, an LNG tank, for example, a 300 cubic meter LNG tank on a ship, or a LNG truck. Okay, so first of all, basic concept. When we fill up a tank, always the pressure go up, because the volume of the liquid that goes into the tank will push up the gas phase, okay? It is like this. Imagine, can you imagine this? This is the tank. the black thing here. Oh, no, the camera. Do you see? Yeah, okay. The black thing of is the liquid level. If we fill up the tank, the pressure of the tank will rise. You see. So if we want to control the pressure while during the process, the filling process, one thing we can do is to remove this gas and put the gas in another place. For example, venting to the atmosphere or another vessel. Yes, we don't like that, okay? Or we can go to boil-off compressor and recondense it, okay? So if we don't want to vent the gas, there is a very clever way of controlling the pressure when you fill up a tank. It's very clever. And so this is the tank. And if we want to control the pressure, the idea is to cool down the phase gas. Please, Sophia. Let's see if the camera can come here. Okay, if we cool down the phase this way, if we cool down with the phase gas, the gas will reduce. Please. Do you see? Again, please. Thank you. So I want to... ¿Puedes poner la transparencia anterior? So, as you see here, this is a tank on a ship, on board, or a LNG truck. Here. This is the clever idea. When you fill up, you fill by the bottom connection, but if the pressure go up too much, then the operator switch the fill up to the upper connection. And you see here, this line with a small sprinkler. So if you, it's like a shower. If you put cold fluid on the top, in the face area, the pressure will reduce. So this is, with this sample, we can control the pressure during the filling up process. I want you to see it again with a bigger balloon. So please, let's try it works. So this is the overpressure. Let's see. Without, okay. Thank you. The pressure reduced, okay? So, okay. Luego recoges el logo, vale. But if you reduce too much the pressure, or you use a very cold fluid, for example, like cold nitrogen, if you want to, if you reduce too much the pressure, then you can get vacuum. And you know that vacuum is very strong person, okay? It's very strong. So I am going you to demonstrate the power of the vacuum, okay, with very simple experiment. Okay. Well, we are going to put here water, a little bit of water. So the idea is to remove the air from the can. I want to remove the air. So if we make water boiling, the vapor pushes out the air. And when we have vapor inside the can, we are going to put here in order to condensate. Let's try it. Mhm. I don't know if we can do it now. Let's try. So, okay. Excuse me by the smell. But I don't know if you can see the can. This is the power of the vacuum. This could happen to your LNC tanks, for example, if you reduce a lot the pressure, okay? Well, let's move to my favorite part of this presentation. It is the firefighting part, okay? So, I don't know if you know this book. This book is the Bible of firefighting in LNG. Here you can find monitors, sprinklers. Here you can find things like low and upper explosive limits. It's a very famous book. So, sorry. Excuse me. Don't buy this book. Okay. It's firefighting part, I think. So, let's see if we can do this. Okay. What I want to show you is what happened, because it's a typical question. What happened if we pour LNG onto water and vice versa? What happens if we pour LNG onto water? LNG onto water or water onto LNG? Okay. Let's see. So let's begin. We are going to demonstrate what happens if we pour water onto LNG. So please put LNG here. So because of the difference in temperature, if we pour water onto LNG, the water will act as a hot part, and the LNG will vaporize much and much faster, okay? You can see the black vapor is the normal rate of vaporization. And if we put water, thank you, it's enough. If we put water here, then the rate of vaporization will increase, okay? It's very nice. Okay. And but now we are going to see this, but with fire, okay? We are going to put fire here, so we have a video, okay? Video. This is a explosive meter. We have LNG in this small can, okay? LNG is not easy to light, okay? And now we are going to pour water. Stop talking, please. Thank you. Slow motion. So, as you see, water multiplies the size of the flame by 5, okay? Now, vice versa. What happens if we pour LNG onto water or into water? Both. If we put LNG onto water, do you remember? LNG vaporizes if everything that is warmer than 160 degrees below zero. So water is warmer than 160 degrees below zero. So if we pour LNG here, it would boil and remains over the water. Nothing happens to the fish. I hope. Okay. Okay. So the camera, please close to the ships, or to the fish. We are so. I don't know if the camera can approach to the little fishes or little fish. They would like the ice. It's cold, so they bite the ice. Okay, because the an ice cream, yes, because the LNG remains over the water, and the only thing is that we can find something ice. Okay, it's a little bit of ice. Okay, well, nah. I cannot find the ice. Okay, okay, here we can have, okay, well, okay. We have a video of this. Okay, but please. So, and we have a surprise. I didn't believe that. So last week I go to the Barcelona terminal and try this experiment. So we pour LNG onto water. It's a dirty pool, but take the ice and we light the ice with this. Light the ice. So I cannot believe it was like a legend. And the real thing, it works. Because we pour here LNG, the ice, the water ice, has small bubbles of gas inside. So if you light the ice, you can find a flame. And also, if you pour water, the flame increase. Okay? So please, video. We have here LNG, and this is the dirty pool. Okay? It's a dirty water. You see the ice? Okay. So I take the ice out. And then, well, I put on the floor and light. And you will see that if we pour water, the flame rises. Slow motion. So thank you for the video. Well, when I say that if we pour LNG onto water in a small scale, nothing happens. But in big scales, we have a big problem. In some conditions, we can find a phenomena called RPT, as rapid phase transition. In the big scales, when a lot of LNG comes into water, because if a lot, it can go onto water and penetrate a little bit. The vaporization rate is so high that we can have real physical explosions. Explosions underwater, explosion over water, and we can, and the most important part for me is due to the ice formation, the explosion is the ice is like a projectile. You can find ice like a rock, because LNG is really cold, going. And Gas de France has in YouTube a video with this. It's called, this phenomena is not well known. It's a complex mixture of thermodynamic and fluidodynamic. Well, we can now put the video of Gaz de France. Only it's a large, long video is a small part. They are pouring LNG onto the water. Well, this is called rapid phase transit, RPT, okay? But LNG phenomenon, okay? Let's continue with the last part of the presentation. Thank you. This part, well, I'm going to tell you a story. Okay. Okay. Please, la última transparencia. You know that in LNG terminals, the ball valves are widely used. We use a lot ball valves. We use ball valves because they shut both sides very well. Okay. This is a ball valve, and open. The fluid can go through the ball, and this ball valve is a closed ball valve. Okay. Okay, la cámara. Okay. Mira a ver si te puedes acercar aquí. No sé qué tal lo veis, pero esto es una válvula de bola. Ahora lo enseño otra vez. Esto es una bola. Está pasando, entonces cuando yo cierro la bola, el líquido contenido dentro se queda. ¡Ostras! Okay, thank you. Okay. Well, siesta time. Okay. So, live performance. So, if we close the ball, the liquid containing inside the ball will remain in the valve. Okay. And as you can know, LNG is a liquid, a boiling liquid. It's a boiling liquid. So we have LNG here through this pipe and valve. This is the ball valve. If we close the valve, the liquid remains inside, but it's liquid. And we have sun here, the sun, heating the pipe and valves. And you know that liquid expands 100 times. So 50 years ago, ball valves explode, and nobody knows why. So I want you to see by yourself that the powerful of the fluid in expansion. Okay. This is the last experiment, and I want you to see the expansion. Okay. So let's wait 5 seconds. Oh. 1, 2, 3. Okay. Thank you. And also, yesterday we make a video for you, but not with this bottle, sino with a big bottle. Okay, so video number 7, please. Enagas offices. Okay. We are pouring LNG inside the bottle, and close the bottle. And to make it more more funny, we have almost 500 ping pong balls.
A ver, poneros las manos en los oídos.
Now in the slow motion. Use the glass, the bottle. Sorry. Okay. Thank you very much for your time. I can take questions. I will happy to do that. But first, I will need 3 female volunteers and 3 male volunteers, because actually we are going to taste the LNG. So please, come on. Yeah. It's a very modern cuisine. Okay. Do you want to taste LNG? Please, come on. Okay. Okay. Thank you. See. Let me. I would like to take a big bite, but all together. So come here, please. See. 1, 2, 3. 1 for me, 1 for you. So I need another one. Toma, moja esta. Okay. So a big bite. Please. Wait a little bit. First, I will take a bite and then you. Okay? Thank you. So when I say 3, I make a big bite and then you. 1, 2, 3. All right. A big applause, please. Please do not don't do that with while you are smoking. Okay. So that's all. Thank you. Sorry. I have to tell you the secret. The Spanish solution to the ball valves. The Spanish solution is to drill the ball, okay, like this. If we put here a little hole. Oh, sorry. This small hole is the solution, the Spanish solution. And this is a safe valve, because through this little hole, the vapor goes to the pipe, to the safe vessel. Okay, thanks a lot.
Okay, thank you, Javier.
The purpose of this small presentation is to give you a basic understanding of the rollover phenomenon. My typical lecture of rollover in Enagas is about 4 hours. So we try to do it here in less than 20 minutes. Okay. My name, well, is Javier Ruesga, and I work in Enagas, so Enagas has a lot of LNG terminals all over the world. But Enagas is the oldest, or has the oldest, almost the oldest LNG terminal in Europe. And I think over 50 years ago, we suffered this problem. Today, rollover is very well-known phenomenon, and this not happen more. But it's important to understand properly how it works. The idea is to give, to remember you 3 basic concepts. Then, in 5 minutes or less, we are going to explain the rollover. And finally, we do a small experiment here in order to explain you how to fill up properly a full containment tank. And finally, I would like to give a question to you and ask if it's possible to have a rollover in a LNG carrier or not. Let me see. So we will start with basic concepts. So first basic concept is that we have a fluid, for example, gas or liquid. If we increase the temperature of the fluid, if we increase the temperature, then the density will decrease, the density of the fluid. Imagine we have a balloon. If we put air in the balloon, if we heat the air, the balloon goes up. So if we increase the temperature, the density will decrease. Okay, basic concept. Second basic concept. You know, LNG is a mixture. LNG is a mixture of several hydrocarbons, methane, ethane, propane, and it's a boiling mixture. So methane boils faster than the other hydrocarbons. So if LNG is boiling, over time, the remaining liquid inside the tank is heavier and heavier because the lighter hydrocarbon boils first, okay, or faster than the other. So with time, this is heavier. So if LNG is boiling, the remaining liquid, the density will increase, the liquid, okay? And this is difficult to explain. The last 3 concepts I want to remember you is the concept of superheated fluid. You can do this experiment at home, but I don't recommend it. But I have here this. If you have a new container, a very new, it probably have a very smooth surfaces. Okay, so in very new containment, you pour water, and then if the surface is very smooth, there is no rough places for bubbles to form. If we don't have bubbles rising to the top of the surface, nothing breaks the surface. So if there is no bubbles, the water contained in the cup can continue heating up beyond the boiling point, actually without boiling. I repeat, it's possible to heat a fluid beyond the boiling point without boiling. What happened? This is a superheated state. Imagine I am the water, I am heating, I want to boil, but I cannot, okay? But because there is nothing to break the surface, okay? So when the surface is finally disturbed, this superheated water immediately and explosively comes to boil. I want to boil, and if I can, this is very important to understand rollover. So we have a video of this super heated fluid or state. Video number 2, please. This is the cup of coffee, and we are going to boil. We are going to break the surface with a coffee, a spoon of coffee. Now, you see the water is not boiling. And we are going to put instantly boil. Probably some of you happen this at home with the microwave. Okay. Thank you. So, well, this is the basic concepts. Okay. We need these 3 concepts to understand rollover. Then 3 minutes to explain rollover phenomena. To remember, maybe most of you knows that. Okay. Imagine we have a full containment tank, or LNG carrier, but full containment tank, with remaining LNG. This LNG comes, for example, from Nigeria. And a carrier comes to a terminal, LNG terminal. Imagine LNG terminal could have 6, 8 tanks. So the carrier comes with lighter LNG. So when the carrier discharges, this could happen. LNG 2. The density of the carrier LNG is lighter. So the density is less. This is a stratified tank. It is perfectly possible. Heavier LNG, lighter LNG. And the difference in density, it could be only 5 kilo per cubic meter or less. Very few difference in density, we can have this marvelous tank with 2 layers. Okay, so lower density and upper density. Okay, well, from the very beginning, when the carrier finalize, from the very beginning, the lower LNG will become to be a superheated fluid, like the cup of coffee, because we have heat coming from the ground and from the air ambient, and the upper layer is like a lid. The upper layer do not allow the lower LNG to boil. So with time, the lower LNG, it has more energy, but it cannot boil. Remember the cup of coffee? After 2 minutes, we have, imagine, this is a large tank. This, after one day, it keeps the energy here. After 1 week, after 2 weeks, after 1 month. So the energy contained in this lower part is very high after 1 month. Okay? And it could not boil, so the energy contained it is here. Okay, so so what happened with time? The density of the heavier LNG will be less and less and less with time, because it has more temperature, and things with more temperature, the density is less, like the balloon in there. Okay, what happened with the upper layer? The upper layer is a normal boiling LNG. It's boiling. So, as we mentioned before, the preferential boiling is methane. So, the remaining liquid, the density is heavier and heavier and heavier with time. And then, when the density equalizes, remember the cup of coffee? If we break the surface, then immediately and explosively it boils. So when this layer density is a little bit more than this other density, it breaks because it's a little bit more heavier. It breaks. And when we break this surface, immediately and explosively, it boils. So we can have a rollover because here in the tank we have a very mixed, suddenly mixed mixture, and the pressure of the tank will increase suddenly. So this is a, Sophia, please. This is a dangerous situation for a tank. We don't want a tank with, we don't want a stratified tank because it's a potential dangerous tank, okay? Yeah, you are operating tanks. You have 8 terminals like this. The operators are operating tanks, and after 3 weeks, after 1 month, suddenly, overpressure, okay? You know the flare. We don't want that, okay? So, you know the normal boil-off in a tank is like this, 1,200 kilos per hour, normal boil-off in a full containment tank. When the boil-off occurs, it can multiply by 100. Okay, the boil-off generated is more than 100 times the typical, the normal or the daily boil-off. So rollover phenomena is we can control, of course, but this is the explanation. And now with this demonstration, Sophia, water, please. So we are now going to demonstrate here we are going to create a stratified tank, and then I will ask you a question about how to solve this problem. So to simulate a heavy LNG, we are going to use water with sugar. Sugar is to make the density a little bit heavier, okay? So we have here the heavier LNG, and we're going to put a little bit color. Okay. So we have here heavier LNG. Okay. Let's simulate lighter. This is gin. Okay. You can smell if you want. Yes. So it's alcohol. So we are going to put here alcohol, and we're going to make it blue. This color and then very intensive. 1, 2, 3. Okay. So now we have a blue LNG. Okay. Let's fill up the tank. This is the tank, and I remember this is the tank with this. Okay. So we are going to put the heavier LNG, and now we are going to do a fill up. We are going to fill up from the top. I don't know if you know that tanks in our terminal has 2 filling ways. You can fill up the tank from the top or from the bottom. Okay? No, I don't know. So we are going to fill up from the top, and we are going to create a stratified tank. Okay? Stratified tank. At the beginning, you should go slowly if we want to make. Maybe this could be a new cap from the.
Don't laugh.
Yeah, yeah. No, this is not explosive. But after lunch, we will use explosive fluid. Okay, so if the camera can zoom, let's see if you can see a stratified tank here. Okay. Do you see it? Okay. So, well, this is a dangerous, potential dangerous situation. So if we want to make this tank safer, a safe tank, we have to remove layers. Layers are dangerous, okay? So tell me one way to remove layers.
I have an idea, with a big storm.
Yes, but you are inside the tank, and this is a nuclear container. So, well, one way is, the pumps in the tanks are, the impulsors are at the bottom of the tank. So if we switch on the LNG pumps, we can send to the grid this part of the LNG. So like this. We can reduce the lower layer up to nothing. Then this tank is saved. Remember, we are talking about, we have 1 month, more or less, to do this. And another way is to recirculating pumps. We should switch on the primary pumps and recirculate. If we recirculate pumps, we mix the tank. So then, please zoom, okay? Then you will see that this tank will convert in homogeneous tank. The 2 layers will disappear, okay, like this. Okay, now this is a safe tank. But with 2 ways, we spend money because we need energy. We switch on primary pumps, okay? So now we are going to say a clever way to avoid stratification in a tank. I'm going to repeat. We have here water, sugar. ¿Puedes poner la transparencia? La 3. What? Vale. Here you can see the lower button, the lower filling. We can fill up this tank by the upper filling somewhere here, and in Enagas we have 2 bottom filling. So we can fill up a tank from the top or from the bottom. First of all, we fill up this tank from the top, and we found a stratified tank. Now, the clever way to do this is to put the lighter LNG in the bottom. And you will see in the camera that the tank is homogeneous itself. So please, camera, puedes poner esto. No, we don't have enough. Okay. I want you to see that. No sé si se ve bien. Quita zoom para que. I want to see the color. Okay. Like this. Well, this is the bottom line or downcomer. Okay. So I want you to see that it's homogeneous and how the blue liquid up and mix itself. Do you see that?
Mhm.
So this is the best way of filling up a tank, avoiding stratification. Okay? So, sirs, now we have a safe tank. So, thank you.
Thank you.
Um,
Here,
I hope you now understand a little bit better the rollover and how to fill properly a full containment tank.
Okay, good. Very good.
Okay.
Thank you very much, Javier. It has been very, very impressive.